It's very common to see laser printers being used in our small, medium, and enterprise offices, but these days we're even using laser printers in our homes. These laser printers are very complex pieces of equipment where you have laser beams. There's a lot of power that goes into these devices. There's a lot of heat and pressure and powdered ink. It's a very, very complex printing mechanism. But some of the advantage is that we're getting some really high quality output out of these laser printers. We can have some very, very precise drawings done, and it comes out very, very quickly. Very surprising how fast we can have these laser printers work and produce some very, very nice output for us. But unfortunately, laser printers themselves have a lot of moving parts, which means there's a lot of opportunity for things to go wrong. There also requires a lot of memory inside of these printers. These printers cannot begin printing anything until the entire page has been rendered inside of the memory of this device, and that increases the costs of the printer overall. And if you have any problems with the toner cartridge, or you just use your printer a lot, it tends to get very messy inside. You have a lot of paper dust inside. You have this ink that might spill out other places inside of the printer. And so you do have to make sure that you're able to maintain this printer on an occasional basis. There are a lot of components inside of your laser printer, but really the heart of the printout begins right here with this laser printer imaging drum. This is a photosensitive drum. It's usually contained within the toner cartridge itself. You would rarely see it being exposed to light like you see here. It's really exposed here so we can see what it looks like. There's usually a cover over it because it's very photosensitive. And if it loses that photosensitivity, you're not going to be able to get a very good output from your printer. But this is what the laser is hitting that is then allowing it to pick up that toner and then place it onto the paper itself. At the end of the laser printing process, we have finally gotten the toner off of that photosensitive drum and placed it onto the paper, but it's still not permanent yet until we apply heat and pressure. And that heat and pressure is coming from this fuser assembly that's inside of the printer. There's a lot of heat and a lot of power that goes into this, and that's why when the paper comes out of the printer, it's a little bit warm. And it's warm because it's gone through this laser printer fuser assembly. A lot of the newer laser printers are designed so that you can easily remove this. If this is something that fails, you can remove it from the laser printer and replace it very, very easily. It's becoming more common these days to see color laser printers, but the color laser printing process is a bit more complex than the black and white process because you have all of those different toner cartridges with all of those different colors inside of it. You'll often find a laser printer transfer belt like this one. This transfer belt is responsible for taking all of the different colors from all of the toner cartridges and putting it onto this belt at one time. Then it does a single transfer from the belt to the paper, making sure that that color representation is done perfectly all the way from the toner until it gets to the paper itself. If you look at the paper tray that's inside of your printer, there's probably this little piece of rubber. It's a very rough piece of rubber that's responsible for picking up that piece of paper and pulling it into the laser printer. If this gets dirty, if it loses its ability to easily grab those pieces of paper and pull them through, or just wears over time, then you'll probably have some problems pulling that paper into the printer itself. So it's very common in the kits that you get to maintain the printer that they send along some additional pickup rollers to replace at the same time as everything else. Another common replacement piece is this laser printer separation pad. This is the pad that's also usually inside of the paper tray that works along with the rollers to grab just a single piece of paper and bring it into the printer. If you look closely, it's a very small pad. You've probably not even noticed that it's there, but it has such an important role. And again, if it gets dirty or it gets worn out, it's not going to work very well. It's such a relatively inexpensive piece of equipment that it's often included with those maintenance kits. So when you're maintaining the rest of the printer, it's a common piece that you would change out at exactly the same time. If you're someone who likes to save paper or you'd like to make the process easier for printing on both sides of a piece of paper, then you need a laser printer that includes a duplexing assembly like this one. The duplexing assembly is responsible for taking the paper and effectively turning it over so that you can print on the other side of it. On very, very large laser printers that you might find inside of printing houses, there's actually two separate paths and it prints on both sides of the paper as it passes through. But we don't have that kind of space inside of these very small printers we would use in an office. So you would need a duplexing assembly like this one that's able to turn the paper over inside of the printer. Before the laser printer can even start the printing process, it has to be able to understand the entire page. The laser printer doesn't print a little bit of a page at a time. It has to print the entire page at a time. So before those wheels even start moving inside of the printer, it has to render the entire page. There are usually specific languages that the printers understand, and your printer driver is responsible for taking your word processing document or your graphics document, converting it into the language that's specific to that printer, sending it across the network to the printer, and then the printer has to interpret it and build out that page. Some very common languages are things like Adobe PostScript. There is an HP specific language called PCL that stands for Printer Command Language, and Microsoft has a standard printer language called XPS, and that stands for XML Page Specification. You'll usually see these on the printer itself. There may be an Adobe PostScript logo, or the driver that's inside of your printer may just say that it is an XPS printer. If we were to look at that printer language that's sent between your computer and the printer itself, we wouldn't be able to really understand what's going on. But these very specific languages are built so that the printer is able to give you a very accurate representation of exactly what you'd like to see on the page. And as long as your printer is designed to understand that language, you'll be able to get the output you want. Once the laser printer is now ready to print, it has now processed the entire page, now things start to move. And inside of the printer is that photosensitive drum we saw earlier. It is spinning inside of that printer, and one of the first things that happens is a particular corona wire inside of the printer charges that particular photosensitive drum with an electrostatic charge. It cleans everything out and makes sure that we're starting with a clean slate when we're now ready to write information onto the page. Now that the electrostatic page is cleaned off with this negative electrostatic charge, the laser takes over and begins writing the actual image onto the photosensitive drum. What it's really doing is changing the charge of that drum, effectively making a positive area where you want the toner to stick. That takes us to our next section, which is the developing section, where the photosensitive drum passes by the toner. And the toner is now going to stick to only the places that the laser happened to hit to begin with. The rest of the page has no toner on it whatsoever. We're really taking advantage of that static charge to be able to stick the toner right to the page. At that point, we move on to the transferring section because the piece of paper is now sliding through the printer. And as those particular photosensitive drum sections go over the paper, we are taking all of the toner and transferring it onto the paper itself. But as I mentioned before, the toner does not stick permanently to the page at this point. We still need to go to the next phase, which fuses those two things together. There's heat and there's pressure that is then put onto the paper to effectively melt the toner right onto the page itself. That's why the paper comes out and it's a little bit warm once it comes outside of the printer. There's usually a little bit of toner still left on the photosensitive drum, so before everything finishes turning, there is usually a cleaning section that goes through. The diameter of this photosensitive drum is not the same size as your paper, so it's usually taking the drum a number of cycles through to finally print everything out onto the paper. That's why this cleaning section is so important. If we didn't clean off that excess toner that was on the photosensitive drum, then we would see some extra marks on the paper that were occurring at different intervals along the page. We want it absolutely clean, so when we finally begin the charging process, we're working with a clean slate on the photosensitive drum. Let's review this process then. We're going to send information into the printer, and before it can even start the gears turning, it has to make sure it processes the entire page into memory. At that point, we can start charging and setting up this electrostatic charge on the photosensitive drum and get it cleaned off and ready for our laser to actually expose the information that we would like to have printed. Then we pass through the developing section where we take the toner and put it into that section where the laser hit on the photosensitive drum. Then at that point, it's very easy to transfer all of that toner onto the page itself as it's going through the printer. Once we get that toner on there, we have to make sure it sticks by applying heat and pressure in that fusing process. And finally, we clean off any excess that might be on that photosensitive drum, and the process begins all over again.